All right, let's try some problems that were on the quizzes. This is from quiz number 2, unit conversions. Now, on the quiz, they gave us this. This is the same thing as that right there. Right? It has atmospheres. Torr, which is the same thing as millimeters mercury. PA and KPA, the same thing with the decimal moved. Inches of mercury and PSI. Oh, they got one other one on there that we did not have on our list, and that's a bar. All right, that's a bar, which is related to Pascal, kind of. All right, let's look at how we would do this kind of problem. All right, we said we want to convert 32.1 kPa into millimeters of mercury. So I make a conversion factor with kPa on the bottom and millimeters of mercury on the top. And I use 101.325, or they have just 101.3 right there. 760 millimeters of mercury. They have 760.0. So that was on the top, that was on the bottom, and then we use the calculator. 32.1 times 760 divided by 101.3, 240.82922, 240.829. Now we gotta, and that's in millimeters of mercury. All right, multiple choice. Which one are we gonna pick? All right, they have this one rounded to the ones column. So 241 followed by an 8, or 241 rounded. All right, answer is C. All right, let's try another one. All right, this one is from quiz number 3, gas law calculations. There's a couple of them here. All right, the question is, find the final pressure of a sample of gas at 0.8 atm, 1.5 liter, that is compressed to 250 milliliters. Assume the temperature remains constant. All right, now, this is one of those changing condition kind of problems. Changing conditions. Now, we have these equations here, but those are kind of simplified versions of this one right here. So let's use this one right here to see if we can figure this out. All right, find the final pressure. Now, we already have a pressure. We got to recognize that that's a pressure, that's a volume, and a final pressure. So we got a starting pressure, a final pressure. So we got this situation. We got a P1 and a P2. Find the final pressure. So P1 is 0.80 atmosphere. And then we have 1.5 liters. Well, that's a volume. So starting with 1.5 liters. And it's compressed to a new volume. Now they say 250 milliliters. And the temperature stays the same. What does that mean? That means that T1 equals T2. So in this equation, T1 and T2 are just going to cancel out. Well, what about the N's? Did they say anything about the N? They didn't say anything about moles. So we'll go with the assumption that N1 equals N2. The number of moles didn't change. So we'll cancel out the N's, we'll cancel out the T's, and what do we reduced it to? We now have P1V1 equals P2V2. That's the same thing as Boyle's law. All right, so we have to solve this equation for P2. Do that algebra on the fly. P2, get it by itself. You're going to take the V2 and move it down there. All right, so our equation would look like this. P1 V1 divided by V2 equals P2, what we're looking for. All right, what we're looking for. All right, now, at this point then, we can put in our numbers. All right, P1, 0.8 ATM. 0.8 ATM, maybe we'll write that in there, times V1, well, wait a minute. Our V's are in different units. Our V's are in different units. That's not good. They have to be in the same unit. All right. Now, the question is, well, what unit should they be in? Doesn't matter. They can be in both liters or both milliliters. Won't matter. They just have to be in the same unit. So if I go from liters to milliliters, that's moving the decimal 1, 2, 3. Hopefully we remember this from ninth grade. I can convert this into milliliters. All right. Now V1 is 15 milliliters divided by 250 milliliters. All right, and that equals P2. All right, now the milliliters will cancel out. That's why they have to match. And then I'm only left with ATMs, which is what you measure pressure in, ATMs. All right, then I'm ready for calculator. 0.8 times 1500 divided by 250. 4.8, 4.8 ATM. ATM, I'm going to keep that in my unit, my answer. ATM. Now, this one's a multiple choice, so they maybe would have rounded it in a different spot. Sometimes they tell us how to express the answer. Let's look at that second question then. All right, this is a whole second question. All right, let's look at this question. At a temperature of, let's call that T1, 298. It's already in Kelvin, so we'll leave it. Occupies a container of 1.4 liters. That would be a volume. 1.4 liters. What volume? I'm looking for V2, question mark. At a temperature of T2 equals 245. Pressure remains the same. All right, that means that P1 equals P2. And that's all they say. All right, that's all they say. Now, which of these do we use? Let's look at this one right here. All right, since P1 and P2 are the same, I'm just going to cross them out. All right, V1 and V2 are not the same, T1 and T2, but what about N1 and N2? They did not say anything about the moles changing. So even though they didn't say it, I'm going to say that N1 equals N2. And I can cross out the N's. I can cross out the P's. So now my equation becomes V1 over T1, V2 over T2. That because the N's crossed out and the P's crossed out, I'm now talking about Charles' law. Right there, Charles' law. All right, I want to solve for V2. Doing algebra on the fly, I'm going to take the T2 down there and move that up there. All right, so now I got T2 times V1 divided by T1 equals V2, my question mark. Putting my numbers in. Temperature's in Kelvin already, so I'm set to go, 298. Volume 1 is 1.4 liters divided by T1, which is also in Kelvin, 245. And V2 then is going to have to end up being in liters, just like V1 is in liters. Calculator says 298 times 1.4 divided by 245. 1.7028. 1.7028. And that's going to be in liters. And what do they say? Round your answer to the nearest hundredths place. 2 digits past the decimal. 0.70. 1.70. And I'm going to call it liters. Liters. 1.70 liters. All right. So in these problems, I can figure out that if it's a changing conditions, where most of these problems are going to be on quiz number 3, quiz number 4, and quiz number 5. So some of these units could cancel out. P1, P2 equal N1, N2, and then it reduces to one of these like that. So that's what we got to figure out. So you're reading your problem. A couple of rules. T's, temperature, always got to be in Kelvin. V1 and V2 always got to match. They always got to match. They got to be the same unit. So if I'm given liters and milliliters, I got to make them the same. Doesn't matter. I can make them both liters, both milliliters. Let's try another one. All right, this is from quiz number 3. Pressure and volume have an inverse relationship, direct relationship, no relationship, cannot be determined. All right, pressure and volume. What is this asking here? What is this asking? Pressure and volume. All right, this is relating pressure and volume. Pressure and volume. Remember that when the pressure goes up, the volume goes down, or vice versa. All right, here's the container with a plunger, and it's got a gas inside there. If I make the volume go down, squeeze it, squish it, the pressure goes up. That's an inverse. The volume goes down, the pressure goes up. Volume goes down, pressure goes up. All right, pressure and volume are inverse to each other. Temperature and volume, pressure and temperature, and volume and moles, those are all direct relationships. Right? When the temperature goes up, the volume goes up. Temperature goes up, volume goes up. Temperature goes up, pressure goes up. Amount of moles goes up, pressure goes up. Number of moles goes up, volume is going to go up. All right? That's assuming the other stuff stays the same. So all the relationships between volume and temperature, pressure and temperature, moles and volume, moles and temperature, those are all direct relationships. One goes up, the other goes up. The only one that's inverse is pressure and volume. Pressure goes up, volume goes down. All right. If I made a pressure volume graph, that's the one that looks like this. If I made a volume temperature graph, it would be a straight line. If I made a pressure and temperature graph, that would be a straight line. If I made a volume and moles graph, that would be a straight line. Those are direct relationship. One goes up, other one goes up. All those cases. In the case of pressure and volume, one goes up, the other one goes down. The other one goes down. If I squeeze the gas so that the volume decreased, all right? So my volume's going down, 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 down. Volume's going down. When is it going to hit the 0? Well, never, unless the pressure becomes infinite. If I want to make that volume get to 0, I'm going to have to make the pressure get to an infinite amount. It's never going to hit the axis. Let's try another one. Here's another one from quiz 3. Quiz 3. A gas with a starting pressure of 84.35 psi. All right, I'm going to call that P1. All right, 84.35 psi. And its temperature. All right, so gas starting with a pressure of and a temperature goes from, so I'm going to call that T1, 323 Kelvin, to a new temperature. I'm going to call that 283 Kelvin, T2. What's the new pressure? New pressure, I'll call that P2 in PSI. If the volume is held constant, what does that mean? That means that V1 equals V2. Held constant. All right, they didn't say anything about moles. I'm going to try to use that equation, so I'm going to assume that the moles don't change either. So V1 and V2, and N1 equals N2. So my N's can cancel out. My V's can cancel out. My equation reduces to P1 over T1 is P2 over T2. That's the special case that we call Gay-Lussac. Right there. We're trying to find P2. All right, got to solve that for P2. Algebra on the fly. Take my T2, move it up here. So P1 T2 divided by T1 equals P2. P2. All right. Temperatures must be in Kelvin. Pressures in PSI, and they asked us put the answer in PSI. So we're set to go. All right. All right. P1 is 84.35 PSI. T2 is 283. Divided by T1, 323. Calculator says 84.35 times 283 divided by 323. Calculator says 73.90417. Round your answer to the nearest tenths place. Tenths place, that's one decimal after the decimal point. So I'm going to round that 9 followed by 0. I'll leave it as 73.9. And it's a pressure in PSI. PSI. So if I were showing my work and given in units, that's what I would put, 73.9. All right. This was a fill-in-the-blank problem on the quiz, and it said don't put units with your answer, so you just want to put that number in there before you hit submit. If you put the units in there, it might mark it wrong. All right, let's jump to quiz 4. Try one off of that. All right, quiz number 4. All right, this had 3 questions, and here's one of them possible. One out of the possible questions. All right, so it says a steel container with a volume of 30 liters. All right, let's call that V1. 30 liters with oxygen, filled with oxygen to a pressure of 9.00 atm, atmosphere. At a temperature, okay, they give us a temperature, 301 Kelvin. What is the pressure if the temperature changes? What is the pressure? All right, so we're looking for P2. If the temperature changes to T2, 402 Kelvin. All right, we're already in Kelvin, not Celsius, so we're set to go. All right, what about the volume? A steel container with a volume. Now, steel containers are fairly rigid, and they're not going to probably change their volume. So I'm saying that that's probably going to be exactly the same thing as V2. So really, the volume's not part of the problem. Volume's going to cancel. So if I'm using PV N over T over N over T, V1 and V2 are the same. Cancel them out. Even though we know what it is, we don't need it. How about the N? Is there any indication that N1 is not going to equal N2? The amount of gas is not changing. It's filled with oxygen. That's not changing. So N1 is going to equal N2, and therefore we could cancel those two out as well. I'm going to reduce this to P over T equals P2 over T2. All right? It's a Gay-Lussac problem. I want to find P2. Algebra on the fly. Take the T2 there, move it up here. P1 T2 over T1 equals P2. I'm ready to go. 9 atmospheres times temperature T2, 402, divided by temperature T1, 301, equals P2. Equals P2. Calculator says 9 times 402 divided by 301, 12.0199. 12.0199. All right, the two temperatures will Kelvin are going to cancel out, and a P is in atmospheres, so this will also be in atmospheres. what is the pressure? They didn't ask it for any specific units, so we'll just leave it as atmosphere. Sounds good to me. Did they say word around it? They didn't say word around it either, so if I leave it like that, I'm going to probably be okay. Alright, hopefully you're getting this. I'm going to keep doing them. Let's try another one from Quiz 4. Alright, Quiz 4. A gas with a starting pressure. Gas with a starting pressure. Let's call that P1 of 84.35 psi. Changes its temperature from, so let's say T1 is 323 K, to T2 of 283 K. What's the new pressure? P2. If the volume is held constant, so V1 equals V2. Well, what about the moles? Is the moles held constant? Let's assume so. Alright, so V1, V2 is the same, N1, N2 is the same. I'm going to cancel out my N's, I'm going to cancel out my V's, and I have P over T equals P over T. I'm looking for P2. P2. Algebra on the fly. Get P2 by itself. I'm going to take that and move it up. P1 T2 divided by T2 equals P2. Let's put some numbers in. Alright. P1, 84.35 psi. T2, 283. Whoops, I screwed up here. The bottom should be T1. T1. So T1 is 323. Calculator says 84.35 times 283 divided by 323. 73.904 17957. Let's see, what do they say? Round your answer to the nearest tenths. So I'm going to round that 9 followed by 0. I'm just going to leave it as 73.9. And I'm going to call it PSI. And that's what they asked for, so I'm good to go. If they ask for something else like atmospheres or kPa, then I might have to convert it. All right, we're going to leave it at that. This is a fill-in-the-blank question, so when you put the answer in, don't put the PSI in there. You might get it wrong. All right. Let's try one more. All right. The volume of a sample of gas changes from, so I'm going to call that V1 of 135 liters to a new volume of 1.95 liters as the pressure remains constant. P1 then equals P2. The gas has a starting temperature of 283 Kelvin. All right, it's not in Celsius, so we're set to go. What will be the new temperature in degrees Celsius? All right, so I'm going to have to find T2, and when I find it, it's going to be in Kelvin, and I'll have to convert it into Celsius to answer the question right. All right, rather than going to this, I want to go to this. But again, they did not say anything about N, moles, so I'm going to assume N1 must equal N2. P1 equals P2, so cancel my P's, cancel my N's. I'm going to reduce it to V1 over T1 equals V2 over T2. That looks like a Charles' Law problem. All right, I'm looking for T2. All right, this is that one that has the unknown thing in the denominator. We got to get it out of the denominator. So I'm going to take the T2 and I'll move it up here. Take the V1 and move it down here. Take the T1, move it up here. Hopefully you followed all that there. So now I'm going to have V2, T1 up, V1 down. I've solved it for T2. I have to get it out of the denominator. So I'm going to just shuffle things around. If I go from one side, I go from down up and up down. There's my T2. All right. That denominator business messes people up. V2, 1.95. T1, 283. V1, 195. Now those are, whoops, did I screwed up here somewhere? V2, oh, that should be, on the bottom should be 135, 1.35. Get kind of messy here. All right. Now I got liters and liters, so that's good. If there was milliliters and liters, I'd have to convert something. Alrighty. Let's see. I'm going to shrink that a little bit. And calculator says 1.95 times 283 divided by 1.35. Calculator says 408.777777. All right. Round your answer to the nearest ones place. Ones place. That's right there. The 8 followed by 7. I'm going to call it 409. 409. No decimal places. Now it says don't include units, but what would the units be? Now this is a temperature in Kelvin. If I put 409, I'm not going to get it right because they want it in Celsius. Remember, to go from Kelvin to Celsius, I have to subtract 273. Subtract 273. That would be 136. 136 degrees Celsius. Now when I put that in, it's a fill in the blank. Don't include the units, but I do have to have 136, not 409. Not 409. Just because of what they asked for. 409 is the correct temperature, but they asked for degrees Celsius, so we'll have to convert it into that to get the answer correct. All right. I could do more. You can ask me to. I'm going to stop at this point. Thank you for watching.